Hi Austin. Let's reduce this fraction by using the method of prime factors. What this means, we're going to take both the top and bottom numbers and we're going to break them down until we have only prime factors. Now a couple of things. Prime means it can't be broken down anymore, right? So 4, for example, we could write that as 2 times 2. So 4 is not a prime. 4 is known as a composite number. However, 2 and 2 are both prime numbers because there's only one possibility of multiplying to get 2. 1 times 2, that's it. And whenever we have only 1 as one of those multiples, we call that a prime number. Also, factors. A factor, each of these numbers here, 2 and 2, would be considered a factor. Okay? 2 factors or more can multiply to give you a product. So in this example, the factors would be 2, 4 would be the product. All right, so that's kind of what's happening here with all this stuff. And what you can do, basically you take each one, let's take the top number here, 175, and we have to come up with 2 numbers, or more if you want to get fancy, but what 2 numbers would multiply to give me 175? Now I literally have no idea off the top of my head, but I know that this ends in a 5. Okay, so let's go with 5 and some other number, because we can do that. When the last digit ends in a 5 or a 0, we can kind of divide it by 5 and we can reverse engineer this answer. So if I get out the old calculator, or not, you can just do it out old school, that's probably even better. 5 into 175, let's divide that through. 5 goes into 17 3 times. I'm going to subtract and get a 2, and I'll drop the next number 5. 5 goes into 5 times. So 5 times 35 equals 175. And we just continue in this manner. Now we're going to go right to primes on this mess. 5 is a prime because there's only one possibility there, 1 times 5. But 35 breaks down into 5 times 7. So what I can do is I can take this 175 over 385. I'm going to write an equal sign. I'm going to write my fraction line. And I'm just going to put all these multiples here. 5 times 5 times 7. Okay? Because these are all the prime factors of 175. Now let's rinse and repeat this with the bottom number. That's what we're going to do. We'll do 385, and we'll do a factor tree on that. Now again, I have no idea what 2 numbers are going to multiply to give me 385. 5 is probably going to be one of them because it ends in a 5. So let's go 5 into 385. Okay, 5 goes into 38 7 times. 5 times 7 is 35. Subtract that out. And 5 goes into 35 7 times. So 5 times 77. Right there. 5 is a prime. 77 is a composite. So we can break that down a little more. That's going to be 7 times 11 is 77. So again, these are all primes. So we have 5 times 7 times 11. Okay? So that's kind of step 1. We've factored everything out. We've done a prime factorization, if you want to get fancy and tell people what you did. Now we can look at any number. Because everything is all multiplying now, everything is all factors, we can do the opposite of multiplying, which is dividing, to cancel this stuff. So I have a 5 over 5, and anything divided by itself always equals 1. So for our purposes, we can kind of just wipe that out. It's gone. We know it equals 1, but it's going to be 1 times all this mess. I also have a 7 over 7, so we can wipe that out as well. Same deal. If it's anywhere, it doesn't have to be straight above like this example. If it's anywhere up top and anywhere down below, as long as you're factored completely, you're good to go. So what do we have up top here? Well, we have a 5 left over. It's really like 5 times 1 times 1, right? But that doesn't matter. And downstairs, everything else is gone except for 11. And now we're in lowest terms. Okay? 5 over 11 is the lowest terms of 175 over 385. All right, so I hope that helps. Let me know if it doesn't.